All right, we're now looking at the second side of your protein handout. What in the world have we got here? We've got a bunch of little three-letter abbreviations. Lice, glue, thra, alla, lice, V, glue, arg. What in the world do those stand for? Well, they stand for, as you guessed, since we're talking about proteins, they stand for amino acids. And so these happen to be the amino acids in one molecule of ribonuclease A. I won't ask you that on the test, but these are the amino acids, the correct amino acids, the correct order of amino acids, the correct number of amino acids in one molecule of ribonuclease A. So how many amino acids are strung together to form one molecule of ribonuclease A? Well, let's see. Looks like 124. So would that make ribonuclease A large protein or kind of a smallish one? Well, I think with only 124 amino acids, it would be kind of one of the small ones. And so, what level of protein structure is this table giving us? This particular diagram giving us primary, secondary, tertiary, or quaternary? This expressing the primary, the secondary, the tertiary, or quaternary. Well, think what each one is. And I think if you look at it, there's nothing in here about shape or how anything winds up or coils or anything like that. This is simply the order of amino acids. Which level of structure is the correct amino acid sequence? Well, it'll be the primary structure, of course. And so this table explains or gives the primary structure of one molecule of ribonuclease A. Now, I ask you to learn the name of one and the structure of one amino acid, just one of the how many? One of the 20. That was which one? Glycine. Glycine has the abbreviation GLY. So I'd like you to pause this video right now, and on your own sheet, I'd like you to circle all the glys on your on your little handout there. Okay, so pause this video. All right, did you pause it? Did you find some glys? I think so. Where's the first glycine? I think it's right here. Hopefully you found it right here with number 68. Where's the second one? I hope you found it right here with number 88. And then where's the next one? Well, I hope you found it right here at number 112. Where's the next one? That's it. And so out of the 124 amino acids that are joined together to form one molecule of ribonuclease A, 3 of those amino acids are glycine, and they are exactly in position 68, 88, and 112, and the rest of the amino acids are in their exact places. You suppose glycine has, not glycine, but ribonuclease A has all 20 amino acids? Well, I happen to know the answer, but I'm not going to tell you. I wouldn't want to, spoil the thrill of discovery or something. I want you to be able to find that out. All right, well, let's move on then and look over at this drawing right over here, and let's kind of get that just a little bit bigger here. Whoa, that was a little too big. There we go. Right smack dab in the middle there. And so what do we have here? We have a bunch of little circles connected. The circles have numbers inside. For example, here's 41, 42, 43, 44, 45, 46. What are those numbers? What do they represent? Well, they represent those amino acids over here, right? And so this is amino acid 41, 42, 43, 44, 45, and how they're connected together. So we lost a little connection down there, it looks like, between 1 and 2. But this is a computerized representation of how the amino acids fit together and how they form a 3-dimensional shape. And so what level of structure is expressed by this diagram? Well, it would be what shape? Tertiary. Secondary structure is not not expressed by this diagram, but now we have the tertiary structure showing the shape that this protein takes. And so this protein happens to be an enzyme, and it has what sort of looks like a mouth here. Well, it's not the enzyme's mouth. There is a special term for that. Call that enzyme's active site. And so every single enzyme has a shape that gives it a mouth, so to speak, except no points for mouth in the next test. You must come up with active site. What fits inside the mouth? Well, it's an enzyme. Not an enzyme, but it is a molecule or molecules that the enzyme works on. In other words, it's kind of like Pac-Man. Enzyme has a mouth. It clamps over the the molecule it's going to work on and lets it go changed. And so the term for the molecule that an enzyme works on is called that enzyme's substrate. That enzyme substrate. So a particular shaped active site for a particular shaped substrate. Remember we said about shape? Very crucial and critical. Now let's look at this diagram over here as we turn the paper. This shows an actual, not actual, but a computerized representation of a particular enzyme and its substrate. Of course, this would be the enzyme, right? And that would be the substrate. The one substrate represented here is glucose, our old friend glucose. Going to get to be an even better friend as time goes on. And this must be this enzyme's what right there? This must be that enzyme's active site? Sure, active site. And so glucose is this enzyme's what? Glucose is this enzyme's substrate. And so, as we look down below then, at the picture below, we see the little glucose molecule down inside here. The active site is closed over the substrate for a very small fraction of a second. When that active site opens back up, glucose will no longer be glucose. It will have been changed. Now, will the enzyme have been changed? No, it will not. It just goes on grabbing glucose molecule after glucose. What's the term for a substance that brings about a chemical change without itself being changed? It's a catalyst. That's right, it is a catalyst. So that's how enzymes work over and over and over again, many, many times per second. We'll get a number, and you'll be kind of astounded by that number. The enzyme grabs the substrate, changes it, lets it go over and over and over again. All right, that's it for this one.